From the beautiful studios of Away Happy, this is Mr. Meyer and 4.5 graphs of the other trig functions. So we've done sine, we've done cosine. So now let's get crazy and do 4 other ones and maybe some more stuff too. Let's see how far we can get now. What do you have to know about graphing tangent? Now, tangent is, we know it's sine over cosine. So you got to watch out that whenever cosine is 0, that's when tangent's 0. But let's talk about the parent function and what I need you guys to know, just like before. Now, first thing and probably the most important thing to mention about a tangent graph is that period is pi. Remember sine and cosine? They had a period of 2 pi. So remember that formula was always 2 pi over b? Well, this guy is always going to be pi over b. So that's kind of important to know. And so for tangent and cotangent, that's going to be true that the period is pi over b. So what do you do when you graph these? So amplitude doesn't really exist because if you want to see what a tangent graph looks like, I can show you right here. That's what a tangent graph looks like. It's kind of crazy. It looks like a bunch of John Travolta graphs over and over and over again, or cubic graphs if you like. And so what do I do here? The first thing that I'm going to do is I'm going to go out and figure out what the period is, just like always. So the period is pi. So since I have a period of pi, that means we're going to go out to pi, right? We are going to cut that in half and then cut those in half, just like normal. Everything still the same. All right, now here's the key, that there are asymptotes in this graph because when cosine is 0, there's an asymptote. And so these asymptotes happen at half the period. So whatever half the period is, that's where you're going to put your asymptote. So you want to do the same thing in the negative direction. Negative pi, cut it in half, negative pi over 2, cut those bad boys in half. And you want to draw an asymptote in at half of the period. So I'll put a little note. Asymptotes. Ugh, why is my pen being funny? Totes at half period. That's real important to know. And then you're just going to sketch your little John Travolta graph in between. Now my doesn't look very even on the left and the right, and I'm sorry. But at this tick mark, so the graph's going to start here, and it's going to go up on the right and down on the left, of course, unless it's negative. At that tick mark, that's kind of where I do the amplitude. Now, they don't call it amplitude in tangent graphs, but I do know that it's got a 1 out in front. And so it's going to be up 1 and down 1 on each side of that center point. And then there is my beautiful tangent graph, right? So this guy would be here and he'd be down on this side and he'd go whoosh. And this guy would be here and on the right side he'd be up, and then it goes like this. And if you want, you could fill those in, but didn't need to. So there you go. That's it. That's tangent, right? Big trick. Remember that you go out and you mark all your tick marks like normal, but then you always do half the period will always be an asymptote. All right, so let me try this one. Here's my graph paper, and you've probably already gone ahead and figured out that the period is pi over 3. So that's my period. And so I'll go out here, tick mark pi over 3, cut that in half, pi over 6, cut those in half, pi over 12, and something else. Negative pi over 3, negative pi over 6, and the two ticks. It's really not that hard, right? We just add the pi over 3 and pi over 6 together. What was that, 4 pi over 9? All right. Amplitude, which is not really amplitude, is called 1. And now I'll go out and I'll draw this. Now again, out to the period, cut it in half as an asymptote. Cut this guy in half as an asymptote. And now I can draw my graph in between. It's going to go up on the right and down on the left. And voila. There she is. That's the tangent graph. That's the period. That's what you're going to just copy over and over and over again until you're bored of doing it or you've covered as much as they want you to cover, right? That's it. Let's talk about cotangent. Now, cotangent, same kind of thing, except for it's going to have one weird thing about the asymptotes and really where those zeros are, where those x-intercepts are, where you start your graph from. Period is still pi, so that's real crucial. So if I go ahead and I'm going to draw the parent function for you real quick. So if I draw the parent, you're going to come out and you're going to mark your period just like normal. So you're like, all right, there's pi, cut it in half as pi over 2, and cut those bad boys in half. And I'll do it on the negative side for you too. There they are. And the same thing with that asymptote thing. But here's the weird part. On tangent, remember we put the asymptotes at the half? Well, these guys, the asymptote is actually at the period. Whatever your period is, that's where your asymptotes go. So it's at the start of the graph and it's at wherever the period is. So that's what this graph looks like. Then right in between those two asymptotes, you'll put your dot. And then on the tick mark to the left, you'll actually go up. And on the tick mark to the right, you'll go down. And that's what your graph will look like for cotangent. Boom, just like that. So up on the left, so you find the middle of the asymptotes, and then you go up on the left, down on the right, and you have yourself one heck of a gorgeous graph. Now the negative out front is going to flip it so it looks more like a tangent graph. The 2x is going to change the period. So let's see what that looks like when I do it. You could probably already tell that the period is pi over 2. So if I go out here to pi over 2, then this is pi over 4. This is pi over 8. And then add those two, you'll get that guy. Negative pi over 2, negative pi over 4. And then these guys, my one tick mark. All right. Asymptotes, because it's cotangent, are at the period and at the initial point, really. And now I can draw my graph. So right in the middle, I'm going to put my dot, my real important dot right in between the two asymptotes. Now, usually it would be up on the left and down on the right, but because it's negative in front, we're going to flip that, and it's going to look like this. So boom, and you have yourself a beautiful graph, and you jump up and down because you are way happy and feeling good about tangent and cotangent. Right, let's jump into secant and cosecant real quick too, because I'm going to do these ones kind of fast. You've already done them. Secant is just cosine, right? So what do you do first? You graph a cosine graph. So I'm going to go straight to the one that's on the right side there. So here's my graph paper. You are going to pretend that this says cosine. You're going to pretend this is 2 cosine 4x. So you would do all your stuff like amplitude is 2, your phase shifts, your vertical shifts, everything. You'll mark out your period is 2 pi over 4. So that's pi over 2. Remember, the period was 2 pi over 4. So that's why it's pi over 2. We're not on tangent anymore, so be careful. Cut it in half is pi over 4. Cut those bad boys in half, right? Come out here to negative pi over 2. Cut that in half is negative pi, and cut those guys in half. Now, this also has asymptotes, so that's the weird part. But again, we're treating it like it's cosine. So now go ahead and do your magic cosine graph where you're like, oh, cosine starts at its highest point unless it's negative. And then the next tick mark, midline, then lowest, then midline, then highest. And that is your cosine, dynamite cosine graph, right? But this wasn't a cosine graph, unfortunately, because otherwise we'd be done. But it's got one little difference in it, not a big one. It goes like this. Wherever your graph of your cosine graph hits the midline, those are your asymptotes, because remember, this is cosine and cosine can't be 0. So boom, all those zeros are now 1 over zeros, and you're like, oh, how sad. They don't exist anymore. And then you got all the high points. Those turn into parabolas that open up, and all the low points turn into parabolas that open down in between their two asymptotes. And there you have your fabulous graph. Isn't that crazy? And guess what? Cosecant's the same thing, but you start off with sine. So I got a little section here about cosecant, but I'm just going to go ask you a question about these. But cosecant would just be, instead of starting a cosine graph first, you would do a sine graph, and then you would just do your parabolas and your asymptotes. And that's it. And I can show you here on Desmos. I should be able to probably pull up a cosecant graph. Let's see. There it is. Boom. Cosecant of x. There you have it, right? Bunch of parabolas opening up, asymptotes, so this would have a normal sine graph. In fact, let's even throw the sine graph in there so you can see it. And you can be like, I gotcha, right? There's the sine graph. Look, all the high points are parabolas up, all the low points are parabolas down. And believe it or not, these guys in the middle, they're your asymptotes. All right, let's take a break, and I'll be right back.